Hello, Internet, and thank you very much for joining us on the Cloud Native FM podcast. And today we are talking about Sergio's book, and we will be relaunching the book Edge Computing System with Kubernetes, written by my friend from Linkerd community, and he is also a Linkerd ambassador, Sergio Méndez, and he is going to share his experience and history behind why and what motivated him to write his book Edge Computing System with Kubernetes by Packt publisher. After his introduction, he is going to give a walkthrough of different chapters of the book, explaining in a practical way how to use the content of each chapter to solve your day to day edge computing problems, and how to run edge systems on ARM devices with the lightweight Kubernetes and one of my favorite Kubernetes distribution, K3s. Thank you very much for joining me on the show, Sergio.
Hi community. Hi internet community.
Yes, a brave intro of Sergio, because now you have your intro is more because you're the author of book right now.
Yeah, so well, it's a little bit interesting to be an author. Well, I am Sergio Méndez. I am from Guatemala. So okay, so um, well, I am already working as a DevOps engineer at Yalo, and I am also a professor and I teach operating systems at the university. So in the university, I teach virtualization, how the process works inside the operating system. So I teach a lot of technologies around cloud native Kubernetes, but in the context about distributed systems. Um, I already have the cloud native community here in Guatemala, and I am a pretty active user, let's say, around the cloud native ecosystem. So that's a little bit about me.
Yes, thank you for the introduction. And we both met, I think, a year ago on the Linkerd side, I think, and the link, and he's now a Linkerd ambassador, and also he's presenting Kubernetes Community Day Guatemala as well.
Ah,
So now,
yeah.
Sergio, stage is yours, and here's a link to follow Sergio on the Twitter. And now you can start sharing your screen and tell us what's behind the book.
Okay, so this is a pretty small presentation. If you can see my camera, here is the book. It's a little bit big, let's
Yes.
say. It's like 485 pages, more or less, 15 chapters. Thank you. So let's start about, well, as I said, well, I am a professor. I'm from Guatemala. I also do some DevOps at some company called Yalo that works about, well, they do some conversational commerce using WhatsApp chatbots. So that's a little bit about me. This is my first book. My first time. This is the book, as you can see in the screen, the same one. Well, I already received my book the last week, the physical book, let's say. That's really, really nice. Well, just to have some context, maybe some of us doesn't know about what is edge computing, what is Kubernetes behind, and what is the relation between these concepts. Let's say that, let's start with edge computing. Edge computing is more like processing the data near to the edge or near to the source of the data. So, for example, instead of getting information from some system and process the information to the cloud and then return the information close to the client, the different thing here is that you are going to process the information close to the source of the data. That's the difference. Let's say that's the strategy in edge computing is different between IoT and edge. Is a different thing because IoT is more like just getting the information from sensors, do small things, and send information maybe to the cloud. Edge computing, the main difference is more like that you have to perform some maybe not heavy data processing, but something that maybe consume more CPU, and you are going to use in edge computing small microcomputers instead of microcontrollers that you are using on IoT. But on reality, edge computing and IoT are complementary because edge refers more to the strategy to process the data near to the source. So that's the difference. So in order to process the data near to the source, well, the benefits that you are going to get about that is that you are going to reduce the latency between how the data is moving from, let's say, from the origin of the processing or the transformation of the data, and how many times this data is going to um, to wait until the client is going to receive this data. So edge computing is going to process the data near to the client, let's say, near to the user, and that latency will be like, well, let's say a cluster is sending information from that location near to the client, and because you are close to the client, that information is going to take not too many time to be received by your client. So edge computing is going to reduce that latency instead of doing all the things across the cloud. And what happens if the internet connection fails? You are going to lose the information. But in edge, the data processing is going to be, let's say, locally or maybe near to the source of the data, and the data processing is near to the client. So that's the main difference. So in this book, I am covering how to use Kubernetes near to the source of the data to implement an edge computing system. But let's say that you are the um, a person that has some knowledge about hardware and that kind of things. So let's say that this book is going to give you the whole introduction to containers, to Kubernetes, in order to create your own system. So that's, let's say, the main goal of this book. You can learn Kubernetes, and this book is going to give you a quick introduction on how to use hardware and Kubernetes, how to create your edge system with Kubernetes, and different use cases around the book. So it's going to cover all the things, all the necessary things that you need to create your own edge computing system. Um, so there are 15 chapters. They are divided in let's say the first chapters are more like installing your lightweight Kubernetes K3s, how to configure your environment, your system before starting to deploy your applications. The other 5 chapters are more about how to deploy your application and different strategies to deploy your application. And the last chapters are more like use cases applied to edge computing. And I want to mention the last chapter, the 15th chapter, is more like a kind of link canvas diagram that you can use to, let's say, that to define your edge computing system uh, using a small exercise, and how to define the different parts, the hardware, and that's really, 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 really nice chapter. So in the chapter 1, it's more about the basic concepts about edge computing. It also shows us how to do cross compiling using Go, Rust, Python, and Java. So all the things on this book, well, are separated in the different layers of edge computing that is explained in the first chapter. So some parts of these systems are running on ARM processors instead of Intel because of they use less power to do the things. So almost in all the chapters, well, a lot of parts are running on ARM and another ones runs in the cloud. So that's the things that you are going to find here. First chapter, examples with Go, Rust, Python, and Java, and do some cross-compiling and generate your containers using that technique. In the first chapter, well, it's explaining there are different layers of edge computing. Um, the cloud layer, the near edge, the far edge, the tiny edge. The tiny edge is where the sensors are running or getting information. The far edge is the site where your Kubernetes cluster is going to run. The near edge, just the telco networks, just the bridge to send the data into the cloud layer. And the cloud layer, includes all the components or the cloud providers that you need or the managed services to complement your local system in the far edge with the cloud. And here's an example of some commands that runs cross-compiling for ARM version 7 or ARM version 8. The chapter 2 is called K3s installation and configuration and describes, let's say, how to create a basic K3s cluster, a single node cluster, and a multi-node cluster. Explains how to replace etcd and how to use MySQL instead of etcd. K3s support that kind of features. How to uninstall the cluster and the different things that you need to install K3s in your devices. Here is an example about the things that you can find there. It's explaining how K3s works. A little bit about how to flash your micro SD card that runs on the Raspberry Pi. Well, all the examples I am based or assuming that the reader is using a Raspberry Pi, but you can use another ARM device like Rock Pi, Orange Pi, and whatever you have using ARM microprocessor. And here's an example of how to install K3s. The third chapter is more about advanced configurations and management about K3s. How to use, let's say, because K3s is running on bare metal on your small device, you don't have like a load balancer. So we explain on this chapter how to install MetalLB as your load balancer, how to install more powerful driver storage for Kubernetes, in this case Longhorn, how to perform backups, restoring K3s configurations. K3s is this small lightweight Kubernetes. Here is an example. Well, these ones are just screenshots that you can find inside the book, in the digital book, let's say. So here's an example about the command how to install K3s. It's like a more advanced way to install omitting the load balancer because you are going to install MetalLB, and some different configurations that you need to run K3s at the edge. So this is pretty interesting because you can use this content not just for, let's say, I am going to install just Kubernetes in ARM device. You can use these same chapters, apply it to a normal or regular installation of Kubernetes. There are a lot of ideas behind the whole book. So in the chapter 4, it's more oriented about K3OS. That K3OS is a K3s distribution as some Linux distributions that includes K3s inside. So you can, let's say, create your own image of K3s and running your K3OS in your devices in a faster way. maybe could be like this content could be a little bit, maybe I don't know if you say deprecated, maybe not, but it's a way that you can use to create like your own K3s distribution, and it's used by Rancher. Here are some examples around that, how to use the ISO image and how it looks running K3OS. But the whole book is more oriented to use the pure K3s command to run or to create your Kubernetes cluster. So don't afraid about that. It's just a chapter. The chapter 5, let's say that you learn cross-compiling in the first chapter, basic configurations on K3s, how to install the storage driver and the different things. So the chapter 5 is more like recollect all the different pieces from the previous chapters and how you can integrate all the things and create a, let's say, a production ready cluster, K3s cluster. So chapter 5 includes the whole parts of the previous chapters to install your Kubernetes cluster. So I define in this chapter 5 some basic architecture or how the cluster will be designed, a multi-node cluster, how the network will be like configured, and here's a screenshot about how to run this Kubernetes admin panel to manage your Kubernetes cluster. In the chapter 6, because the chapter 6 and starting from the chapter 6 and to the chapter 10 is more like deploying your applications. So in the chapter 6, you are going to learn how to install ingress controller, in this case nginx, instead of the default traffic load balancer. So you are going to learn how to configure the thing using different ingress controllers, and you are going to learn how to install this cert manager to add some TLS certificates to your deployments. So if you are reading this book, in the first chapters, there are small explanations about how to perform basic commands to deploy an application, check the services, create a load balancer, etc. So this is like a more advanced chapter that you can integrate TLS certificates and how to install an ingress controller. So will be a nice chapter. Here are some screenshots about the configurations that are inside the book. Some diagrams. The chapter 7 is more about GitOps using Flux at the edge. So the whole chapter is focused more on how to use Flux to update your applications that are running at the edge. So in this chapter, I implement a basic CI/CD pipeline, let's say, using GitHub Actions. How this thing is going to create your container, how this thing is going to run at the edge, and how Flux is going to update your application that is running at the edge. And I cover, let's say, like the whole steps, even installing the Grafana dashboard that Flux has to show the state of the applications. I think that is really, really nice Flux scenario because supports really, really nice how to update applications at the edge and has pretty good support for ARM devices. I didn't include Argo CD because in that time Argo doesn't support that, but I think that Flux is more lightweight than Argo CD for this kind of applications. So you can simplify your life using Flux instead of Argo CD in this kind of scenario. Here are some small screenshots about that, the architecture that the GitOps strategy, let's say, that I implement in the chapter, different things. Well, the whole book have like YAML files in some GitHub repository that I am going to show at the end of the presentation, and you are going to have access to these files in this GitHub repository. So don't afraid about that. The repository has all the examples, the images, and everything. The chapter 8 is more like implementing observability, but at the edge. And the only one, well, and the cool software that you can use and has a really nice support for observability at the edge, and it's a service mesh at the edge, is Linkerd. So you are going to implement some traffic splitting strategy using Linkerd, but running on our ARM device. Here are some examples about the things that you are going to find in the chapter: how to install Linkerd from zero, how to deploy this traffic split and everything, some diagrams. Well, each chapter includes a small portion of theory before starting with the practical things about installing from zero the software and how to configure your things. All the chapters has the same structure and also has some final questions um, to evaluate yourself if you learn a lot of not about the chapter, and different resources that you can check after reading the chapter. Chapter 9 is more like is more oriented or focused on serverless and event-driven architectures. So in this chapter, I covered Knative and cloud events, how to implement the serverless functions, how to implement a small event-driven call for this function, and how to use cloud events to standardize how you create your microservices or your APIs, let's say, is the thing that you are going to find on chapter 9. Here is the example about how to create a function on Knative. The majority of the examples and container images are designed to run on ARM, but you can modify just commenting one parameter to generate these Docker images or container images to run on an Intel microprocessor. Here is a small diagram that is included in the chapter. This is like just a small like kind of content that you can find. Chapter 10 is more oriented about NoSQL databases running at the edge. So I cover MySQL, Redis, MongoDB, PostgreSQL, and Neo4j. So with that, I cover SQL and NoSQL databases from different kind of type of databases like relational databases, key value databases, documental databases, object databases, and graph databases. That is the case of Neo4j. So the idea behind is that whatever need you have in your system, you have these examples about how to configure or to install these different databases. And the cool thing about this chapter is that all these databases are tested to run on a rare ARM device. So you can check this chapter and include some basic theory about how to select or to choose your database depending on your needs using the CAP theorem. And I have here some example about how to run MySQL at the edge. So you can learn a lot of things about databases if you are not strong in that topic. Chapter 11 is more like doing some monitoring at the edge using Prometheus and Grafana. So I in this well, these chapters are more like use cases applications. This chapter is like capture temperature using some sensor, get the data, insert the data, and show this data on store the data on Prometheus and show the data on Grafana. That's basically what it does. These chapters includes a basic architecture diagram, the whole commands about how to install Prometheus and Grafana, so you can learn Prometheus and Grafana on this chapter. It's not like focused on to run this thing just for Intel microprocessors. And here's like a graph showing the temperature about the data that is capturing the sensor. And here's Prometheus. So this thing is the thing that you are going to learn on chapter 11. Chapter 12 is like a kind of, let's say, modification of chapter 11, but you are using this protocol called LoRa to send information at long distances, let's say from 1 kilometer to 10 kilometers. So you can use that kind of things. Well, here I have a small sensor using the LoRa device. So you are going to learn how to configure this kind of devices using the Arduino interface, the editor, let's say, of the software that you are using to flash your Arduino devices. But in this case, we are going to use a ESP32 device that includes LoRa support and that kind of things. So this is like pretty nice chapter. The diagram about the hardware that I am using, some screenshots about showing this information. In this case, in this chapter, I am storing all the data in a MySQL database, and I'm showing the data from a Grafana dashboard, reading the information of this MySQL and how to configure the whole thing to implement a small garden system, smart farm garden, or smart farms use cases scenarios. Chapter 13 is more like geolocalization applications. Well, in this chapter, I'm using a GPS module using K3s and a NoSQL database to implement a geo-tracking or geolocalization system, something more or something similar to a Waze application or a Google Maps application, something like that, but using a Raspberry Pi and everything. It's pretty nice. You can find here the diagram that you are driving in a car, you have your Raspberry there running and capturing all the GPS information and showing a map the position where you are moving on your car, and you have some report that shows all the information collected in a day range, and I think that this chapter is pretty cool. Personally, I love this chapter. It's pretty nice. Chapter 14 is more like using computer vision. So I am using the camera and Kubernetes. Well, the previous chapter also used Kubernetes. This chapter is more focused on video analysis and object detection using K3s and a small neural network accelerator. In this case, the Google one, but you can use the Intel neuronal network accelerators. I am using in this chapter Redis, OpenCV, TensorFlow Lite, scikit-learn, and my GPS module. And the small diagram, how the system it looks, detects persons, trucks, cars, and different things. how the script that is capturing and detecting objects and giving warnings to the driver is going to show. And the last chapter is more like a chapter to organize or to help you with, well, with all this information. This is a kind of methodology using a diagram to create or to define your whole system. So you are going to use this diagram. There is a PDF that includes like these sections that you can fill using some questions that is inside this PDF. So you can answer the questions about what are the features of my system, the purpose, the challenges, the people that is going to build the system, the cost, how to automate the system, the data, the security about my data, which devices I am going to use, the sensor, the communication, which metrics I am going to define, what things I am going to running on the cloud, what things are going to run at the edge. And that's basically the whole content of the book. um, this presentation is in this slide, is in this link, sorry. The repository that this book uses is this one. It's on the GitHub Packt Publishing Edge Computing System with Kubernetes. If you buy the book, is inside, this information is inside the book. I am going to update this repository to, let's say that we have a Discord channel, a YouTube channel, etc. These links are the links that you are going to find, let's say, a video about the chapter 1, chapter 2, well, on YouTube, videos about the different chapters. Right now, I am trying to build this content. We have this Discord link that will be available for 7 days, just for security. We can discuss, and I want to support the readers if they have questions about the different chapters. So you are going to find there some channels or text channels to discuss about this chapter. So to give you support, my Twitch channel that I am going to use, like maybe do some live demonstration or extra content that you want to learn about this. I want to also support the Spanish user, of course. This is the whole book. This is the Amazon link where you can buy the book. And where are another places that where you can buy my book? If you have the Aurelia account, you can use the Aurelia to access my book. Also, you can buy the Packt subscription to read the book. And I think that on this month they are going to give a discount of $5 for my book. So, and if you want to ask me personally and send me an email, here is my email and my Twitter account. You can also send me an inbox on Twitter, and I am constantly tweeting different information updates about contents or blog posts, maybe about the content of this book. How you can help me? If you buy the book, give me a review on Amazon. I think that that thing is going to activate the algorithm, let's say, and helps a lot the reviews there, because if a book has reviews, it's like, well, the people is reading the book. So you can share about my book. Here's the book, or you can also create content around the different chapters. So that things are going to help me to sell the book. So I think that that's it in general. It's like a pretty walkthrough about the whole book. So
Thank you. Thank you, Sergio. It's been a wonderful conversation around all the books chapter. So just to spend 5 more minutes on some questionnaire session. So can you tell some audience around what is the attended audience is for the book? Is already mentioned in the book as well, like who is the right audience to purchase that book. But who do you think is going to be most beneficial from your book in the future?
Okay, I think that if you want to learn Kubernetes, could be a good book to learn Kubernetes. I think that for the beginners could be nice. For the beginners that works on hardware solution, could be also, well, I think that could be the book for them. So if you know, let's say, how to program an Arduino device or something like that, or you are working with hardware, but you want to know about containers and Kubernetes, I think that this one is the book. And as I mentioned in some tweet, for example, if you also read this book, Kubernetes Up and Running, or Kubernetes Cloud Native and Kubernetes Applications, or something like that, I think that that's the name of the book from O'Reilly. I think that this book could be like the next book to read. I think that could be beneficial. You can also learn Kubernetes with these ones, with this, but it's not oriented, let's say, 100% as a book for learning Kubernetes from zero. More or less, I think could be possible.
Yes.
So I think that is more like the audience for this book.
Yes, absolutely, absolutely. So
And
just
of course, if you want to create an edge computing system, this is the book too.
yes, absolutely. That's basically the question. Like if you're working with the edge devices or want to have a data closer to you, I think this is a perfect place to be to learn some of the concept from this book. Because I think if I look at the curriculum of the book, there is structured around how to learn some of the basic concept from the Kubernetes, and then let you learn how to install and configure K3s cluster in a highly available mode, and then you end up doing the ingress controller because you want to have every application access outside the cluster. And then we can see in the chapter that the Linkerd service mesh, K3s with the GitOps, we can see monitoring observability is also in place, and logging and how to collect data from the different devices and to circulate them in a Grafana dashboard. So I think it's covered the whole cloud native stack in there. It's not just for the ad devices, but if the curriculum is definitely very much aligned with the Kubernetes need as the companies or as the individual are looking forward to reading the book. And also for the final few questions, like, do you plan to update it on a daily basis or on a not daily, like monthly or a quarterly basis to update this book because some new things coming up on the edge community or some new things pop up? Do you plan to update this book on some quarterly basis?
Okay, let's say that it's necessary. Well, let's say because this is the first edition, it's like a kind of impossible to be continuously updating the book. But I want to, on the GitHub repository mainly, I'm going to mention an errata, a place where I am going to post the different errors found inside the book. But in my different social networks, mostly on YouTube and Twitch, I am going to add extra content because, let's say, for example, on the chapter of GPS, it's like just like a kind of proposal or a theoric proposal about how to implement an H system using GPS modules. But there are another and easier ways to implement this kind of use cases using GPS. So let's say, for example, I think that I have to do that, create content about GPS modules. So I think that maybe not updates officially in the book, but maybe updates or extra content that you can watch on my YouTube channel or maybe on Twitch. So could be like complementary in that way. After that, let's say after 1 year, I am going to collect these different videos and things and the comments from people that are answering me, and I am going to include this content maybe in the second edition of this book. So I think that that could be the way. First, like get the book and read the content that is inside, complement this content with my YouTube videos that I'm going to create during this time, on Twitch and everything. And in that way, I think that you can complement your knowledge, or we can expand the content of the book in an official way, let's say, using my YouTube channel. So I am going to create a lot of content around that, not just specifically for each chapter, an extra content about, let's say, well, now let's do the same thing of this chapter, but using this another strategy or this another software. So that's the idea
Yeah.
that I have right now.
Yes, absolutely. That's a perfect plan to go about it because people like to see what's in the mind of the author when he's writing the book. And if some of the demos that you have in your channel in the future in the form of hands-on guide will be definitely useful for the all of the user who are reading your books because they want to see like how the things work actually in the practical way. Afterward, they can read the book and can see all the emphasizes on. But I think Sergio is also have some KubeCon talks on his some Knative, serverless, edge computing, GitOps. They're all listing on the CNCF YouTube channel. So this is another place for you to go about and watch those sessions that's previously done on the KubeCon and NA. So that's another place for to ask question as well. And also, I definitely encourage you to join the Discord server that the Sergio is preparing and also read give your feedback because on top of your feedback things can be improved and things can be flourish. So Sergio has been, I'm not expert in edge computing or these kind of stuff, but I think people are watching us later would be a better for people to ask questions. Would always be in a Twitter handle Sergio, you can ask question on there. And thank you very much, Sergio. We hope to have another session, might be in the next year, to cover some of the topic in the practical hands-on way. I'm interested in Knative and serverless, how things work in the edge computing system on that part. Could be a wonderful topic in the future podcast as well. But thank you very much, Sergio, for taking your wonderful time and sharing a wonderful information for the beginners to understand like what are the content is curated for and how things work and how things align according to the Kubernetes syllabus or the Kubernetes knowledge. So thank you everyone for joining or listening to this podcast. And if you enjoyed the podcast, please share your comments on the chat below. Or if we miss anything on the edge computing, you can definitely add those in the chat section. I will definitely share this information with Sergio so he can be collaborate with you on the daily basis. So thank you. Stay safe, stay healthy. Have a wonderful day, everyone. Bye bye.